Okay, so let's get started. So this is the last web server Kuppi I'll be conducting. Today I will talk about optimization, and in optimization I will talk about I will optimize this web server in 3 areas. Okay, so there are mainly 3 parts we need to focus on. See, so the first one is this. Okay, so over here, as I mentioned in the last copy, we are sending the entire response as one file, and if the response file is quite big, then it's going to take a really long time for the web server to provide this response to the client. So we're going to fix that. What we're going to do is that we're going to break down the file into smaller chunks and send chunk by chunk. So not going to send the entire file at once, so we are going to send it chunk by chunk. Hopefully that will improve the performance. And the second one is server side and client side caching. So what we are gonna I will explain what we are gonna do there. And the last one is multi-threading. Okay, so hopefully this video won't take long, and we will be able to finish this quite quickly. And a small disclaimer: if I sound a little bit funny, that's because I'm suffering from a small cold. So hopefully I'm not very unclear, and you guys can understand what I'm saying. So yeah, as I said, let's start with this line. Okay, so over here we are sending the entire file as one. So if we take a look at the function, if we take a look at this send file function, so what it says is, so this is actually I want to do this now. Give me a moment. Okay, so over here it's so this is the function, so function prototype. Alright, so as you can see, it takes an output file descriptor. So this is the file descriptor of our socket that sends this file. So this is, and this one is the input file descriptor. So this is the file descriptor of our opened file, so whatever we open, and then here we have the offset and the size t, so and the count. So in count, what it does is that count specifies the amount of data that this send file function should send. So over here what we are saying is that we send file should send the entire file. Alright, so so today what we need to focus on is this offset. So what offset is, so what offset does is, so let's say for an example these are the content. Okay, so for an example, let's say these are the content we need to send in our file. So these are the content that's included in our file, and this will be sent through this send file function to whatever the process that requested this. So what we do is that, so we define the output file descriptor and input file descriptor, as I said, and the count specifies where to stop. So this function starts from the beginning and reads and sends up to the size defined by this count and stops there, and sends this bit. So let's say so the count, so the value that's specified in the count parameter stops the function from reading up until this one. So it's going to send this bit to whatever the process that's requesting. Somehow what it always starts from the beginning. So what offset does is that offset, the value of offset pushes the function to start from another point. So if let's say the offset specifies a value that matches to this size, so then what the function is going to do is the function is going to start from here and then going to read up until the value that's specified with the count, and that value is going to get sent. And then if we update offset by the amount that was sent, it's going to start from here and then you can read up until the value that was specified by count until it meets the end of the file. So that's what we are going to do. Okay, so instead of saying send file, what we are going to do is that we are going to create a variable of t data type. So offset, so of t is a data type that's defined in one of the header files up here. Alright, so it's one of the it's defined in one of these header files, and then if you want to look it up, you can do a small Google and find it out. I'm not going to go into it because it's not something important at the moment. Okay, so what we're going to do is that we are going to go for a while loop and check offset is smaller than the file size. So sorry, it should be offset, not off the offset. Okay, there you go. So what we're going to do is that we are going to send the file. We should pass the memory address of offset, and the size should be buffer size. So let's go through this code one by one. So over here, this is the send file function we used before. Okay, so over here what we does is that we are going to send only this amount. So previously, if you take a look at this, we sent the entire file using one command. Over here what we are going to do is that we are going to send only this amount, and this offset variable gets updated automatically. Okay, so and then it's gonna start from where it finished. So that's basically what it does. SIST is another variable. Okay, it's so if you are familiar with SIST is a variable that can hold the maximum value. So it's maximum value. So but SIST can only hold positive values. SIST can hold negative values because its most significant bit is used for the sign. So hope you guys can remember what we learned in last year's computer systems module. So it's just that in the in the size data type, all the values are used to represent the size. In the size data type, the most significant bit is used to represent the sign. So whether it is positive or negative, and the rest is used for the size. SIST is used for to detect errors. All right. So if it's if the value is less than 0, that means there was an error. So what we are going to do is that we are going to say error send new file, and then we are going to break the loop. So that's it. So that's first bit done. So right now what we are doing is that instead of sending the file as a whole, we break it down into multiple chunks and send chunk by chunk. So let's compile it. Let's see, and let's take it out. It's running. Okay, so my browser is there. So let's check out localhost. And yeah, you get the hello from the Caesar, and if I go to about, okay, there's something wrong with HTML code, I don't know. Okay, so then that's that. Good. Let's access this. Okay, small error. Let's rerun it again. Okay, so we got a small error. I'm not so sure why that happened. So we'll check that out in a little bit, because let's see why that happened. Okay, let's go back to the code and let's do something else and let's check it out. Okay, so okay, yeah, so that's how you send the file. So I'm not so sure what, and let's see. Okay, so it's gonna take some time. So okay, so yeah, until that clears out. Okay, so until we get the port cleared. At the moment port is already in use. So let's talk about caching. Okay, so caching we can do in two ways. So caching can be done two ways. One is client side caching, and the second one is server side caching. So what caching is like, your phone speed dial. So what caching does is that it stores most recently accessed files in the memory. So when there's a request, we can send that file instead of reading from the file again. So if you take a look at how we do this one, we go back to the send response function. What we do is that whenever we get a request, we read that file, and then we read the content from the file. Okay, so the file path is defined in this fp variable, and we send that we read the data into a we read the data, so then we send that through a socket. The issue with this is that sending process is quite expensive, so it takes a little bit of time. So what we can do is that we can store the read data in memory, and if it gets another request, what we can do is that we can instead of reading from the file, we can send it straight out of memory. The second thing is so that's server side caching. So and then there's client side caching. So what we can do is that we can in client side caching, I'll do that as the last step, because otherwise it's a little bit confusing. What you have to do is that you have to update the header and include 2 lines. Okay, so when you include those 2 lines, let's include those right now and I will explain them. So I'll be using this until we are at the end. So okay, so these are the 2 lines. Okay, so what this does is that we say store this file in the cache for 24 hours. So over here you specify the time in seconds. You can change the size as whatever value you like. Okay, and over here it's stored in 24 hours, and e tag is a special value. It's a special value that you can be used to uniquely identify a file. Okay, so that's how the file is recognized. So yeah, so what this does is that when I send the response, I tell the browser, hold this file in your web browser for 24 hours, and if the user makes a request within 24 hours for the same file, the browser won't send a request to the server. It will get the content from the browser and render it, so that the number of responses the web server gets reduced, because it's stored in the web browser. Okay, so that's what it does. So right now it is caching for 24 hours, so you can cache it for 10 seconds if you like. Okay, so I usually don't use this until the last moment, so let's comment this out. And yeah, so that's client side caching. Okay, and hopefully by now the port is cleared, it's working. So let's see what was wrong. Okay, so let's go to my browser. Okay, let's resend the request. And now it works. Okay, okay, I don't know what went wrong there. The only change I did was comment this one out, and I added those 2 lines, and then I uncommented this print line, and now it's working. Okay, so that's a little bit of C for you. Sometimes it's a little bit confusing, but it works. Okay, so during the while, if it stops working for no reason and you can't figure it out, just rerun the program and hopefully it will work. Sometimes it works, sometimes it does. Okay, yeah, it's C is sometimes a little bit unstable. Okay, so as you can see now, if you go to here, so I'm not telling the browser to cache the file for 24 hours, but I'm sending the file by chunk instead of sending the file, and I still get the response. Okay, so if I try to access a different file, and okay, maybe my browser isn't working.
Quickly typed procedural.
Okay, let's get this one out. Okay, text in my server. Okay, something's not working. Either way, you guys get the idea, right? So I'll check what's not working here. It's obviously not related to cache, so I'm not going to go into that right now. But yeah, so sometimes this code can be a little bit unstable. That's why we have other programming languages actually. So yeah, let's go back to the code. Okay, so It's nothing big actually, so it's no need to figure that one out right now. So yeah, so that's over here if we send the file by chunk and it works. Okay, even though there's some error over here probably. Okay, let's see. And the other thing is this. Okay, right now it's commented out. It's commented out because like I have very small number of files, and if they get stored in the cache, then I would have to clear out the cache of my browser. Otherwise I won't be able to make requests again, and if all of these get stored in the cache, then I won't have any files to work with. So because of that, I can use a very small number for caching, but then again it's no point there. So these two are commented out. So that's client side caching. Then what we are going to do is then we are going to do server side caching. So in server side caching, as I said, what we are going to do is that we are going to store the value in memory. Okay, so for that we are going to create a new data type. So what we do is let's define the max cache size. Sorry, max cache. Let's say 64, or you can use whatever you like. Okay, so what we are going to do is we are going to create a new data type. Let's call it cache entry. Okay, so what we are going to store, we are going to store a few values in this one. So the first one we are going to value is, the first value we are going to store is the path of the file. Okay, so let's say 512, and then the data. Okay, it's going to be a char pointer. You'll see later why. And then I also like to hold the file content type, because then I don't have to process again. Content, sorry, it should be underscore type. It should be SQ32 bytes. So hope you guys are familiar with structures. So over here what we defined a new data type. So we are going to create an array of this data type. Okay, so what we are going to do is cache entry, then let's go cache, then max cache size. I'm getting an error. I need to use the struct viewer. Struct. Okay. So if you don't like to use struct, you can use type def. Okay, if you are familiar with type def, you can use that with no issue. So if you use type def, then you don't have to like repeat the struct keyword over and over again. There's another way you can use type def. If you are familiar with it, then no problem. Other than that, then my suggestion is not to do that, because tomorrow is Viva. So there's another way you can use type def. So this is the other method. So in the previous one you use two commands. Okay, so you create the structure and then convert the structure into type def. Over here I'm gonna do it in one. So cache entry. So this one is also valid. What's this here? No, it's right. Something wrong. What's this? Oh, I used it. I didn't use the struct keyword. So yeah, the advantage is that you don't have to use a struct tag over here. Okay, so this is another way, but I'm not going to use this one. I won't be using type def in this code because it keeps it a little bit simple, even though you end up using keep repeating struct keyword over and over. Okay, so what we did was that we created a new data type called cache entry, and we created an array of 64 entities. Okay, and now what we're going to do is that we are going to create a new function called cache file. So let's call it cache file, and then we are going to pass the should be char. Okay, so what we need to keep in mind is that the path acts as the unique identifier. So here the path is unique, so you can recognize each entity or each entry using the path, because each path specifies a unique resource. Okay, so we can use this path as the so that's why we are storing the path there. So you can recognize, you can uniquely recognize it. Let's create another one called is cache. So what we're going to do is we're going to pass the path into this. I will go through the function later. Okay, so what this function will do is that it will take a look at the cache, and using the path it will see whether that file is cached or not. If it's cached, then it will return 1. If it's not, then it will return 0. Okay, you can use boolean as well if you use import std bool. I won't do that because it's at complexity. So right now let's take a look at cache file. Okay, so it's the process response. So here we have the process response function. Over here we can create our void cache file. I'm gonna need two things, not just one. I'm gonna so in cache file I'm gonna need the file path and also the content type, so it makes so it requires less processing. It makes the job a lot easier. So let me double check quickly. Yeah, so if I go down here, so let's call it this file path, and there's another one. Let's add p to indicate that this is a pointer, and then this one's going to be, what is content type. I should be get content, content type. Okay, VTC. Okay, so yeah, so what we're going to do is that now we got the cache file. So the first thing what we need to do is that we need to find a empty cache slot. All right, so yeah, sorry, not find an empty cache. What we're going to do is that give me a second. Alright, so now let's first of all let's prepare the data. Okay, so if you take a look at this, we need to store the size as well. I completely forgot about that. So what we're going to do is that we're going to stat files, that we're going to store data about a file as well. So if I go down here, okay, so where is it? There you go. So what we're going to do is that first of all we are going to open the file. Okay, so it's opened fd equals open file path, and then read only. Okay, so we are only going to read it, and then what we're going to do is that we are going to create a variable to hold the data about the file. So struct stat file stat, and then fstat file descriptor is, sorry, it should be opened fd, and then maybe address of file, no, sorry, it should be file stat. Let's take a look at the function prototype of file stat quickly, and fstat file stat, it should be fstat. So fstat, it returns an integer. So we take a look at the return values, fstat just return value. On success 0 is returned, on error -1 is returned. So what a small trick here, if like we can store the value. So let's call this like what? I can't use the word stat. Let's call it fs. Okay, so and then if it's less than 0, that means there was an error. So what we can do is that we can terminate the function right here. So that means that there was an error in something, so we are not going to cache the file. Okay, so and then we call return. So okay, so we did two things over here. We opened the file and we stored the file data in this file stat variable. Okay, so now if you take a look at the content we need, we technically have 3. So the next step what we are going to do is that we are going to dynamically allocate space and then store the value of the file in that memory space. Okay, that's what we are going to do. Before that, we need to find an empty slot in the memory, in the cache. Okay, so what we are going to do is let's go. Where is it? Okay, there we go. So let's find a empty memory slot, max cache size, and then I plus plus. If cache I data equals that means it was empty, otherwise we would update the value of data. That means we found a empty memory space. Alright, so what we are going to do is that we are going to create let's call it the data b. So we are going to dynamically allocate memory. Okay, alloc size of cache entry. I should be struct. Okay, so struct cache entry. So if this one is null, that means there was an error allocating memory. So what we are going to do is we are going to print out the error allocating memory to store file data, and then we are going to close the open file socket, otherwise there's going to be a memory leak. Open shit opened, and then we are going to return, because there's nothing we can do, because the allocation failed. If it didn't fail, what we're going to do is that we're going to update the values. So what we're going to do is, let's take cache I path. The path is going to be file path. Okay, and strcpy cache I. Content type is going to be what was passed to the function, and then cache I file stat equals file stat. And so over here the file stat is the member of this structure. Okay, don't confuse yourself. Over here in the first that file stat is this one, and if you go down, this file stat is this. Okay, so if I like change the variable name or something, so yeah, so that's how it should be. Okay, so there's no need of using an underscore, otherwise it's confusing. So that's that. And then oh sorry, we did that. And then I forgot to do a small thing. What we need to do is that we need to read the data in the file into the memory. We didn't do that, so we allocated the space. Now what we are going to do is that we are going to use the function called read. So let's check it out and read. So over here what it does is that read attempts to read up to a count bytes from file descriptor fd into a buffer starting at buff. So what we're going to do is that gonna return SID. Okay, that's what it's going to return. So yeah, give me a second. Yeah, so let's do that. Size t, let's call it bytes. Okay, bytes read is equal to, we're gonna read. So the file descriptor is open file descriptor, and then the buffer is that data p thing, and the size is the size of the file, so it should be file stat stat size. There you go. So that's how you do it. And so this one's going to return the size of the value that was read in bytes, or it's going to return negative value as far as I know. Let's check this one quickly. Return value on success the number bytes on error minus one will be returned. So somehow if the value we read isn't equal to the size of the file, that means there's an error. Okay, sorry, it should be this size. That means there's an error. So what we are going to do is that we are going to print out an error message. Let's call it reading failed. And then what we're going to do is that because we didn't write anything, we don't have to do much, but it's always a good practice to like give me a minute. So yeah, because we didn't write anything, there's no need to, nothing to worry, but always just to make sure that let's always set the data variable to null, because that's how we find a empty memory space. Okay, right, I know we didn't do anything to the memory space at the moment, but it's always good practice just to do something like this, so that there won't be any errors. And then we can stop the execution. And yeah, one thing, we need to also close the, okay, it should be close. Okay, so hopefully that's clear what I did over there. So what I'm going to do over here is that look for a empty space in the cache. Okay, so if there's an empty space, I'm gonna allocate some memory dynamically using malloc, and then gonna read the values in the file into that memory space. If there's an error, then I'm gonna stop the caching process. Over here I close the file descriptor and everything, otherwise there will be a memory leak. And we also need to free this. Okay, completely forgot about that one. We need to free that as well, because we won't be using that. And okay, if this we do all of this if there's an error. If there isn't an error, what we're going to do is that we are going to copy the file path into cache entry, file path, file type, file stat, and then the last we're also going to copy data, and let's call it data p just in case, because it's more clear. That indicates that it's a pointer. So if I go down here, let's call it data p. You can use whatever you like, it's up to you. This is just my preference. Now here let's call it p is equal to data p. Okay, so yeah, that's how you cache a file. So that's the initial idea of caching. So you don't, when the client makes a request within a short period of time, the server doesn't waste its resources trying to read the file again over and over. What it does is that it just basically read from the memory and provide the response. So one issue with this caching method is that if someone asks during the Viva, so in this caching method, the one I implemented in this code, is that if you can take a look at this, over here we defined the array. Okay, over here we define the array, and then we keep filling it up. Once it's full, the latest request don't get stored in this cache. So that's a small error actually, but I'm not going to address that at the moment because we have quite a large cache here. So if someone asks what the issue is, that's the issue. So what happens is that so when the cache is full, the older entries should get cleared and the new entries should enter there. So we start writing from the first one, so from the 0th index, and keep writing and then keep writing. And once it's full, when there are 64 entries, we go to the first entry, remove all the cache data there, and store the new value there. Okay. So you can do that by keeping track of an index. Okay, so over here, if you like index. Okay, so and if you have like a global variable that keep track of all the indexes. Okay, let's start with 0, and then if you like keep updating it, that means that the values with the lowest lower indexes were older compared to the higher indexes, so you can remove the ones with the lower index. So that's one way you can address that. And yeah, that I'm not going to go into that code because it's a little bit complex, but the idea is simple, but the code will be a little bit hard to implement, but hopefully you guys can understand what I'm trying to say over here. And I'm not so sure whether you guys implement this exact code, so I just go through a rough overview. Okay, so over here we cache the file. Okay, once it's cached, so what we need to do is that we need to find a method whether is it cached or not. So over here, so cache file. So we are going to call this function is, sorry, it should be an int. It should be an int. Oh my goodness, int. Cache file. F. You can name it whatever you like. So what we are going to do is that we are going to create a for loop. I equals 0. Max cache size I plus strcmp. And what we are going to do is that we are going to compare each cache entry with the file path of the requested resource and see whether it is cached or not. So what we are going to do is that so cache I file, oh sorry, it should be, I think it was path or something. Yeah, it's path. And then we're going to compare it with file path. Oh, sorry. So if it's equal to 0, that means that these two entries match. That means that the the resource is stored in cache. So it's gonna return I. So it's gonna return. So it's here is the returns around 8. Okay, it's gonna return the value of the entry, and if it's not, then it's going to do is that it's going to return -1. Okay, so that's a way you can check for the whether a file is cached or not. Okay, so the last one that we need to do is that if the file is cached, we need to be able to send the cache file. So what we're going to do is that send. So let's create another function. Let's add the function prototype here. What's the issue? Is cached. let's get rid of this quickly. Okay, we have small error. What's that? Int. Oh, sorry, it should be isCache, right? Yeah, small. Mindfuck that. So let's compile to make sure that there aren't any compilation errors. Okay, we don't have any compile time errors. Okay, so let's create another function. So this one won't return anything. What it's going to do is that send cached file. It's gonna take an integer for the index. I think that's pretty much it. Give me a moment to double check quick. Yeah, I think we can do it like that. So yeah, so send cached file. So what we are going to do is process response is cached. Okay, let's create that here. Void send cached file int. Let's call it index. Okay. So what we are going to do is let's call it start cache entry. Let's call it entry. It's equal to cache. So sorry. So, man. Index. Okay. So we store the entry in this entry variable. Okay. So otherwise we would have to keep repeating this thing. So now when we are sending a response, what we have to do is that we have to create a header. Okay, we have to create a header, and then the other thing is we need to send the file. Yes, that's what we do. So there's a small thing I forgot to mention. Okay, so that's okay. I will make the update now and I will explain it later. So right now what this create header function takes is the length of the file. Okay, but we are going to need another value to pass to this one to identify the value to as unique identifier to that. So instead of sending along, what we are going to do is we are gonna send one from the stat data type. Okay, let's go down and let's remove this. Let's call it stat fs. Okay, so it stands for file stat. Over here, instead of that, we're going to use fs dot st size. So what we are doing here is that instead of passing the size, we are going to pass the file stat. So over here it should change to this. So we aren't passing the size, we are passing the stat itself, and we are going to need another value from the file stat for this thing, for etag. I will do that after this caching thing. Okay, so that's why I stored the file stat here as well in the over here in the cache range. The one member is file stat. Instead of storing the file length, I stored the file stat because of that. Okay, so right now let's create a create header, and for the create header what we need is, okay, so we are going to need a buffer. Let's call it header buffer size. Okay, and then let's pass the buffer to it. The next one is code, so obviously it's going to be 200 because it's in the cache. That means that resource exists. And then the content type, it should be we should get that from here. So no, it's edit from entry content type, and then I should also pass entry dot file stat. Okay, let's check whether there are any compile time errors. No, we are all good to go. Okay, so we got the over here, so we created header. Now let's send the header. Okay, so yeah, give me a moment. So the code is yeah, I forgot one. So I need to pass another integer, which is the socket file descriptor. Forgot about that one. So I need to pass two integers instead of one. Okay, let's go down over here. Where are we? Over here. So over here, what I need to pass is the sock fd, and then the buffer is going to be header, and then size t is going to be strlen header. When you are calculating the size of a string, use strlen instead of size of. I'll explain that later if you guys request it. Okay, just if you need it, just drop your message. I'll explain it in a later Kuppi. Okay, so what we're doing is that we are sending the header. Okay, so we send the header, and after that what we need to do is that we need to send the we need to send the cache file. Okay, so give me a moment. So yeah, so what we are doing is that we are basically doing what we did in the previous send file thing, but there's a small change. In this one we have to update the offset manually. So here's a code. Okay, so let's change this cached file into entry. Okay, so let's go through this code one by one. Let's see this one as well. I might have, yeah, let's, so a little bit of vim. It's entry, right? Entry, yep. Okay. Maybe there's an issue here. What happened there? All right, it should be data p. That's what happened. Okay. Should be data. There we go. That should fix the error. Yeah, that fixed everything. Okay, so yeah, what we do is that we create another offset. Okay, and we check whether the so basically what we did in the previous one, but instead of using send file over here we use send, because right now we aren't using a file, but we are using we are sending data that was in memory. Okay, we are sending a file. Because of that we use send, and in send yeah, if you take a look at the function prototype of send, so send, so over here it says sockfd const void. So in the difference in send is that it starts from the pointer that's specified in this second argument. So data p points to the first one, first character, and if we keep using pointer arithmetic and updating the value, then it gets updated. So it's going to start reading from where we left off. Okay, so and the size t, so this is the length of what we are sending, and the only difference is that we have to update the offset manually. So if you take a look at send file, okay, send response, in send file we don't have to update the offset is automatically managed by send file function. Over here we have to manually update it. That's the only difference. So that's caching. Okay, so it's gonna send this cache file. Okay, so now let's check for any compile time errors quickly. No, we are good to go. So what we are going to do is that in the process response function, Okay, so we check whether the method and the so we check whether the request is properly structured, and then we check whether it uses a right method, and then we check whether it's asking for a file type that's supported by the web server. If not, then we try to send the response. Okay, so in send response function, one thing we can do is that so what we can do is that we can check whether the file is cached or not, and if it's not cached, we're gonna cache it and then use send response to send it. Otherwise, we're gonna send the cached one. So yeah, so what we can do is that let's check it out here. If so now let's create something like this. So it's gonna return an integer, so let's call it cache stat, and it's gonna go is cached, and we're gonna pass the file path into it. File path should be file, no, it should be path. Okay, and if cache stat. So what this is going to do is that, so if we take a look at the code, it's going to return a value from 0 to 63 if it's cached. It's going to return the index of the cached entity. Okay, so let's say that there's this file we are requesting and it's stored in 5th index, so it's going to return that. Okay, otherwise it's going to return -1, because this can return 0 as a value where the file is cached. What we should be doing is that we should check whether cache stat is less than 0. That means if it's greater than 0, sorry. So that means file is cached and the file is cached. Okay, so what we're going to do is that we're going to say send cached file. Send cached file, we're going to send the socket file descriptor and then the index, which is passed by the cache stat function. If it's not, that means the file is not cached. So, file is not cached. So what we're going to do is we're going to say cache file. So cache file, we're going to file file path and the content type. So for that we're going to use get content type and going to pass file extension and then this, and then inside this we're going to call this send file. So hopefully that's clear to everyone. So if not, I will go through it quickly. Let's quickly check if I find line minus. We don't have it. So what we do is that we check. So in cache is cached. So this is a function. It loops through the cache and check whether the file is there, whether that requested resource is cached or not. And if it's cached, then it returns the index of that. Okay. If it's not, then it's going to return -1. That's why we are checking whether the value is greater than 0, because if it's less than 0, that means the file is not cached. So if the file is cached, then we can use this and send the file. If it's not cached, we can cache the file and send the response using send response. So yeah, that's as I said. Let's check for compile timers. We don't have any, and let's check this one out. Hopefully it will work. Yes, what is listening? Yeah, it's working. Oh wait, let me share my browser. Okay, there you go. So it's working. Okay, so I made the request, and if I make a request again, I get the same file. So right now, instead of reading from the file, it send it from the cache. So I can add some print statements. Okay, there's a reading. Oh, we forgot to check for a null what? Null pointer. No, let me check. Quickly fix that. go back to my code editor. Okay, so I got this reading failed error. Okay, not so sure why I got that. Let's quickly check it out. Where is it? Sorry, it should be cache file. Yes, reading failed. Byte thread is not equal to this size. You know what guys, you guys take a small break. I will quickly find out what's wrong and tell it to you guys. Okay, so did some old school ChatGPT there, and it's suggesting to change this. Let me quickly check. Oh yeah, I'm sharing the right screen. Yeah. So no, the issue was that it says reading fail and it says success. So technically, it didn't read the entire file, but it read the content. So what we need to do is that we only thing we need to check for is for an error. And hopefully that'll fix it, and you guys saw how it worked, right? So that's caching. Okay, so after that we have to talk about multi-threading. Okay, so what is multi-threading? Okay, so that's right now we have done two types of optimization. We send in the data in chunks, and then we are also caching. Over here we have to enable this thing. At the moment it's disabled because I have commented it out. Right now we are doing server-side caching and client-side caching once this one is enabled. That's all. Okay, and then the last one I'd like to talk about is multi-threading. Okay, if you implement this in your code, then obviously you're gonna need to check this one out. So let's talk about multi-threading. I had some example code somewhere. Let me quickly find out where I put that. Where did I put it? Oh. Sorry. You are. Not this. Right, there you go. CD tutorial. Oh, this isn't running. Where did I put that? Oh, there. Must be. Oh, there we go. thread.c. Yeah, let's open this up in Visual Studio Code. Okay, okay. First of all, let's take a look at this one. You don't need to take a look at the multi one. So let's delete these two quickly. Okay, so over here, okay, I have function. So what this does is so I have this function called print. Okay, so it runs for 1 billion times. Okay, over here I have a for loop without a body. Okay, that means it doesn't do anything. Okay, so this one's quite equivalent to this. It's the same thing. Okay, I have a for loop, it doesn't do anything, but it runs for 1 billion iterations. Okay, so I usually use this syntax. So this is a for loop without a body, and you guys will encounter this when I do DSA Kuppis. This one is quite frequently used there. So what we do is that we have an outer loop, okay, for loop. So it starts at 0 and goes up until 9 because it's less than 10. And it for each iteration it calls this print function. When the print function is called, it runs for 1 billion times, and then prints the value that of the outer loop. So the value of the outer loop is passed to the print, and it's printed here. So it runs for 1 billion times. After executing for 1 billion times, it executes this part. Okay, so let's first of all check this one out before we talk about multi-threading. So hopefully you guys can understand. So let's call it GCC I don't know, dot out. So it should be single, right? Yeah. So yeah, we got the executable. Let's execute it. Let's dot out. So yeah, there you go. So right now it was 0, executed for 1 billion times, printed out 0, 1, 2. Okay, it's gonna take some time. Okay, that's the point of running it for 1 billion times, and that's how I can show the difference between multi-threading and single threaded as well. So let's talk about multi-threading. Before talking about multi-threading, let's talk about what is a thread. Okay, so a thread is like when we say a thread is a order of commands. Okay, so we have these processors in our computer, and these computers can execute the commands we give to the computer. Alright, so the problem with an issue is that a processor can execute one command at a time. It can't execute two. So think of it as a person. So there's a person, and that person can do one thing at a given point of time. That person can switch between works. Okay, that person can do one thing at one time, work on it for several seconds, and do something else, and then do something else. Like the person can switch between tasks, but at a given point of time, that person can only work on one. Okay, the same thing applies to a processor. So the processor can execute one command at a time. So when we say a single thread, that means that so it's kind of like not imagine. So let's go to the whiteboard quickly. Give me a minute, it's asking for my sign up. Okay, it's loaded. I guess yes, it's loaded. So give me a minute. Yeah, hopefully you guys can see what's happening here. So let's say yeah, let's say we have our processor like this, and a single thread is like this. Okay, so in this there's gonna be commands like move one value to this memory location and stuff like that. So and then print stuff. So so what the processor, this is the processor. Okay, this is the processor. it can execute only one command at a time, so one order of commands. So this one is going to be an order of commands. Okay, so there's going to be several commands, so it can only focus on one of these at a time. So this is we call this one a thread. Okay, so if your computer has multiple processors, that means it can focus on multiple tasks, but if it has only one, it can focus on this. So what we are doing in multi-threading is that instead of like, so if we so in the previous code we executed only like, if you go back to the code, okay, so over here we executed one after the other. So we finished one loop, then went to the other for loop. So no, sorry, we finished one iteration, then went to the other iteration, then to the other iteration, like that. So we did one after the other. So that means everything happened one by one. But what if we tell the computer to do all of them simultaneously, so all of them at the same time? So that's what multi-threading is about. So what, instead of providing one thread, we are going to give it multiple threads, like this. Okay, so let's quickly clean this one up. Let's use this. So over here, now the processor has 3 threads. Okay, so we don't target a processor when we are multi-threading. What we are targeting is the entire computer, entire CPU. So there are 2 ways a multi-threaded program can execute. Okay, one is parallelism, like parallelly, and the other one is concurrently. Okay, I'll explain this one by one. So what parallel, what if the multi-threaded program is being executed parallelly, that means these threads are being executed on 2 processors, 2 or multiple processors. So this one shouldn't be here. This thread should be on this processor. So let's call it processor 1, and this one is processor 2. Okay, so this one is processor 2. So so what happens is that, let's remove this one. So what happens is that both of these are being executed at the same time. Both of them are executed at the same time. So that's executing parallelly. But most of the situations, okay, even though your computer is multi-threaded, these multi-threaded programs get executed concurrently. And what concurrently means, let me draw this in a straight line. Let's figure this one as well. Okay, so this is a straight line, and yeah, let's say that these 2 are threads. So in concurrently, what happens is that the processors switch between threads. So it does a little bit here, then a little bit here, then switch back to a little bit here, then back to here. So it looks like the processor is working on 2 computers at 2 threads at the same time, 2 processors at the same time. But what it's doing is that it's switching between the tasks really fast. Okay, that's what's happening. So imagine, an analogy I can give is that, imagine a kitchen. Okay, so in parallel processing, what happens is that 2 chefs working on 2 dishes. Concurrency is like when one chef is working on multiple dishes. So the chef switch between the dishes time to time. It at a given point of time, he or she only works on one dish, but overall working on multiple dishes. So that's what concurrency is. Okay, so in multi-threading, what happens is that I'm telling the computer to execute a set of code that's inside a function in a different thread. Okay, so let's go back to the code. So over here we have this single threaded one. Okay, so every command given in this computer will be executed in one thread. So everything will happen one after the other. But if you take a look at the multi threaded one, so it's a little bit longer. Okay, it's nothing serious, but it's a little bit longer. Oh, before that, so that's multi-threading. Before that, uh, there's something I need to tell you guys about. Test.c. Okay, so what I need to tell is ways we can pass arguments to a function. Let's quickly go through that. So define st, so it should be std your touch. So okay, something's wrong. What's that? Okay, give me a second. I will quickly find out what's wrong here. Oh, I used define, didn't I? Oh, right. Small brain error. Back, yeah. Okay, so if you guys didn't notice what happened, instead of include, I used defined. So yeah, that's what happened. A little brain fog going on. So okay, so let's create a function called add. Okay, so what we're gonna call is add. No, let's call another function called print. It's easier. Let's call it print. Okay, so what we are going to do is that we're going to pass an integer to this function, and that what that print function is going to do is that it's going to print it out. Void print, and let's call it x. Printf. What is the value? So it should be d. Okay, so this is a very simple C program. Hopefully you guys can understand what's going on over here. Okay, I'm getting an error because sorry, it should be printf. Okay, so this is a very simple program. Okay, let's compile it. Test.c. Okay, so yeah, what we are doing is that we have this print function, and it prints the value. We pass into this. So this is one way we can pass value. So we call this pass by value method. One way we can pass values to a function. We pass the value, entire value, and there's a pass by reference method. What you do is that you pass the pointer. So this is something you should be familiar with. Okay, so avoid confusion, let's call it xp. And over here, instead of passing a, I should pass the memory address of a, and let's update this to xp as well. Okay, so this is another way. I forgot to execute one. So before compiling this one, let's execute this. Okay, so I don't think I have to execute the previous one. Okay, so there's a small issue. Oh yeah, over here I have to dereference the value. Okay, compile, and then let's execute. So it's a value, it says value. So this is one method. So what we are doing is that we are passing the memory address instead of the value. So there's another way. So we can pass a void pointer as a void pointer. Okay, let's call it p, and then we can cast it inside the function. So hopefully this is clear. So what we are doing over here is that instead of passing, so over here we are passing the value. Okay, let's cast this one as well, so it's a little bit clear. You don't actually have to cast it, it gets casted automatically, but for now let's for clarity let's leave it like that. So what we are doing here is that instead of passing it as an integer pointer, we are passing it as a void pointer, and then what we do, we cast it back to an integer pointer and use it here. So before you ask about use cases, you will see in about 5 minutes when you do multi-threading. Okay, so yeah, just hold on to your horses. So that's one way of passing one. This is something new for most of you. We can pass a value like this using a void pointer. Okay, so let's say that you want to pass multiple values. So let's say that there is a function called add. Okay, and obviously it's gonna need two values. Okay, it's gonna need two values to perform the calculation. So but we can only pass the values as a void pointer. So in void pointers you can only pass so void pointer is only one value, you can pass multiple values. So what we can do, then we can define a structure, let's call it args for now, args. Okay, over there we can define two values, x and y. Okay, and inside here, okay, let's call it a and b, it's easier. So b. Okay, so let's define two variables here. B is equal to what's it as? So what we can do is that we can create a new variable struct args called args. Let's call it arguments. So otherwise you might find confusing. Okay, and then arguments dot a is equal to a. So over here this a is from this member, and this a is this variable, and then again arguments dot b is equal to b. Okay, let's create our add function here. What it's going to do is that it's gonna take a void pointer, and what we are going to do is that we are going to cast it back to args pointer. So what we are going to do is arguments p is equal to struct args. It should be p. P. Okay, so now if you want to get the value, what you can basically dereference it as well. Like you can do something like this, struct, sorry, okay, arg is equal to the dereference the value of arguments. Okay, you can do this as well. So if you don't want to use pointers, but I have a problem with that. So what we're going to do is that return the arguments a plus arguments b. So this is something we can do. Okay, so hopefully you guys understand what's happening over here. So oh yeah, let's call the function as well. Instead of print, let's call add. Okay, and let's hold the value in this variable called val. So what we are going to do is we are going to pass the memory address of arguments, and what is the issue? the issue here. And void pointer. Let me quickly check. So I don't have to. Oh, I'm missing a parenthesis actually. Oh, that's the issue. So yeah, that was the problem. Anyway, so technically you don't need to use this actually. So I use this so you guys can understand it better, but you don't have to explicitly say that it's going to be passed as a void pointer because it gets automatically converted. Okay. So if we like, let's test these values. Let's add something easier to read. Something like 20. Okay. So now let's compile this code. Dot out and it oh, I'm not printing the value. Printf, let's print the value back. Okay, compile again and then execute it. It returns 30. So the code is working. So what I'm doing over here, okay, so you can see the entire code. So for this add function only takes a void pointer. Okay, so its arguments should be passed, so its parameter data type is a void pointer and arguments should be passed as a pointer, and it gets automatically converted into a void pointer. The issue over here is that compared to the print function, in add function you have to pass multiple values. Okay, in print function you only have to pass one value, so there's no problem, you can just pass it and cast it inside the function and use it whatever you like. But in void pointers, sorry, in add function you have to pass multiple values. So what you do is that you define a structure. Okay, in this structure you hold all the values you need. Okay, technically speaking you don't need these two lines. I can directly add 10 and 20 here. Okay, I don't need these two lines and it would do the same thing. Yeah, it prints out 30. That's the same thing. So we store the values in this structure and we pass the memory address of the structure to the add function, and then we dereference it inside here using this line. Okay, and then let's call two variables. So if it's not clear, let's call it a, and a should be arguments p a, and int b should be arguments b, and instead of returning that, let's just return a plus b. What happened now? Yeah, here we go. So what happens is that so it gets passed into this p pointer. Okay, and then we cast it back into the data type we want, and it's stored in this pointer name, and then we get the values and store them in variables called a and b, and then we return the value. Okay, that's one way we can pass values to a function, multiple values to a function. Okay, so we need that because in multi-threading, okay, so to create a thread there's this function called pthread create. Okay, and the pthread create is defined in this pthread.h header file. So what we do is we have this pthread create, we give the function we want, and the values we need to pass should be passed as a void pointer. Okay, so if you want to pass like multiple values, then you have to create a structure and then use pass that. Okay, let's first of all let's take a look at this function. So over here when you are multi-threading in C, okay, you need this function pthread create. So let's take a look at that now. So and pthread create. Okay. So for pthread create, you pass a thread and the function, sorry, you pass the thread attributes of the thread, second argument, then the function and the arguments you want to pass to the function. So over here we pass the function, we don't call the function inside this, we just pass the reference of the function. As you can see, we are using parentheses. We pass the function and the arguments we want to use. Okay, I will once you go through this code, you will understand what's happening here. So yeah, that's what we are doing. So one thing, there's two conditions to a function that gets passed into pthread create. Those two are that the function should return a void pointer and it only can accept void pointers. So there are these two conditions that should go through. Okay, so what we are doing here is that we create a thread using this. So like let's say that let's go for a simple one. What we call sm.c, something like that. It's not the most creative. Okay, let's include stdio.h, include pthread.h. We're gonna need these two. What was the other function I have used here? String.h. Okay, we won't need string.h. Okay, so let's create a small print function. Okay, so and then let's what we're going to do is let's define the function here. Let's call it args. So we're going to need it in integer. So what I'm going to do is that I'm going to basically create this thing. Okay, what we have over here in this. So let's have it side by side so we can see what's happening. So first of all, let's cast it into an int pointer. So let's call it xp. Yeah, let's cast it into int pointer args. Okay, and after that, what I'm going to do is, as I said, I'm going to execute this for loop. Let's start at 0. Understand 1 billion times 1 2 3 1 2 3 1 2 3, then increment. After that, I'm going to print the value. Should be dereference the value of xp. So why am I getting an error? Oh, should be printf. Again, I made that error. Okay, there we go. So okay, so what I'm going to do here is that for int I equals 0. Okay, it should be equals 0 I plus 10 plus plus. So yeah, okay, you guys will see a small error, just don't mind it, I will explain what's happening here. So let's call it int i2. Oh, i1 is fine as well, i1, and it's going to store the value of I, and then to the print function I'm going to pass the memory address of i1. Okay, so yeah, everything looks fine. Okay, so now we try to execute this. gcc, what is it, sm.c -o sm. Did you see the error or not? Oh yeah, you see it. Oh, yes. Yes, oh, you don't get to see it. That's fine. So yeah, it works. Okay, so it works as the previous one too. Okay, so what I'm going to do right now is that I'm going to multi-thread this. Instead of like executing this function print, I have to return null here. Sorry, surprised I didn't get negative. No, because I have to return value here, because this isn't a void function anymore, it's a void, so the return type is a void pointer, so it obviously has to return a pointer. Over here I'm going to return null because I don't have value to return. So what I'm going to do here is that okay, so I'm going to execute this print function in another thread. So I can create a thread using this variable name called the thread t. Okay, so that's the data type we use. Let's call it thread. Okay, so be thread. All right, and so what I'm going to do is I'm going to create another thread. P. Okay, it will be thread create, and then I'm going to pass the memory address of the thread, so it should be thread, and then it asks for attributes of the thread, and I'm going to pass null because we don't have any attributes, and then it asks for the function which is print, and the arguments we want to pass, it should be I1. Okay, so because this is a multi-threaded program, so what happens is that this one gets executed in a different thread, and when it gets, after executing it in a different thread, we need to remove that thread from the program, otherwise it's gonna give us some errors. So what we're gonna do is p thread should be detached, p thread self. So what I'm saying over here is that destroy the thread after running the program. So right now if I run this code, it will look a little bit funny. So let's give it a try. Okay, I didn't get an output. What's that? So yeah, so it's not gonna run the way we expect it to run. So okay, because it's a small time frame, let's go through this quickly. So that's how you create a new thread. So over here, if you can take a look at, if you can see, I'm creating 10 threads instead of one. So this is how you create multiple threads. Okay, and over here I'm also creating this input array called input, sorry, ivals. So what happens is over here I'm giving a memory space for each thread. So instead of creating a array, if I pass a variable, you should do this by yourself actually if you are interested in doing it. So what you're going to do is that all the threads going to write to the same memory space, so it's gonna give the same value instead of different values. So if you want this code, just let me know, I'll give you the code. So over here we have this pthread create. Okay, this is another way. I just remove this. Okay, so what happens here is that I loop through the code. Okay, and I get the value, and then so I have created this structure. So that structure is going to do what? It's gonna. I don't think I need this one. I don't need that. So this is the array. Okay, so this input array. So in that input array, so it's input data type, it belongs to the input data type. It's gonna store an integer, a message of 20 bytes, and a float value. Okay, those are just arbitrary values. They don't mean anything. So when the function gets executed, so the for loop gets executed, what I do is that I go to the ith index and then go to the outer loop and store the value, and then multiply the I value by 56. I can multiply by 56 by 2, something like that, 3. Okay, and then I'm going to store the value hello in that memory space. Alright, then what I'm going to do is that printf. I don't think I need this one either. So I'm going to pass that memory space as arguments into the print function. Alright, so then it's going to receive this and going to execute it in its own thread and going to give the output. So let's try that one out now. So it's multi.c. multi.c. Okay, no issues. If we execute m.out, I didn't get anything. Why is that? All right. So what happened was the program stopped executing before the threads got time to execute. Okay, so we won't have that error. So it's a problem with this one. Okay, so we use this vthread detach function. So the problem is, so we won't have this issue when we use this method in the web server, because web server runs in a while loop. So no matter what, the web server will not stop executing. Over here, because we aren't running it inside a while loop, what happened was, before the thread got time to execute, the function stopped executing. So the main function, so it created 10 threads, and then after creating the 10 threads, it straight up went to this and stopped executing the program. So if I like put this inside a while loop, in an infinite while loop, so this time I might get something. Okay, so it's okay, so it kept giving the output. So yeah, so that's what happened. I get an output, but I don't get the output I want. So what I'm going to do here is that I'm going to use another function called pthread join. Okay, so what pthread join does, okay, let's go to the whiteboard again quickly. Okay, so over here, let's say that there are multiple threads like this. So okay, oh, that's wrong one. Okay, there are multiple threads like this. So now let's erase all of this. Yeah, yes, all. Okay, so how a program or this program works is that so it starts with a single thread. It starts with a single thread, and once it reaches a particular point, it reaches that pthread create function. Once it reaches that, it starts creating multiple threads like this. And then once there are multiple threads, these ones gonna get executed concurrently, like I explained earlier. So it's a little bit of this, little bit of this, little bit of this, and then a little bit of this one, like that. So they're gonna get executed concurrently, and once they are done, we call a pthread join function. So what it does is that it joins all of these threads together, and then put it back into a single thread, and then start executing from there. So what's important about pthread join is, let's say that this function So this thread isn't finished, isn't done executing, so it's still being executed, but the other ones are done. So what it does, it is that it waits until the other this thread is also done. So this thread is also finished. So if you go back to the code, so over here pthread join waits until the thread is finished. Over here I'm calling it inside for loop because there are 10 threads. Okay, so I'm waiting until each thread is finished, and once they are finished, I finish the program with this line. So it after that it comes to the end and the program finishes. So if I like try to execute this one, and let's try to execute this. There you go. So I don't know if you recognized or not, but it got executed a lot faster. Okay, so we can track the time. Okay, we have the both executables. So let's see how much time the single threaded function takes, single threaded code. So you can use this time command to see how long a particular program takes to execute. So let's see how long this one takes. It's good for rough estimation, so you can't like estimate the you can't get the exact time a program takes. It's good to estimate the time a program takes. So over here what we are doing is that we executing this part, the single threaded program. Okay, so it's taking its time. Okay, so it took 38 seconds and 38.152 seconds. Okay, so this single threaded program. So if I multi-thread this program, so there's a small difference. So it's basically the same code. Okay, or in this one, in this multi.c, I have the basically the same code. Couple of changes. One, that this one is multi-threaded, and the other one is that I'm passing multiple values instead of one. Okay, over here I'm passing a message and a float as well. Okay, those are the only two differences. Like I can get rid of those if you like want to, but there's no point because like you guys will see. Okay, so that's the time the single threaded program took. It's so for fair judgment, let's remove this then. Okay, let's create one. Let's remove this. We don't need this. Let's quickly update the code. Let's create an array of integers and let's call it input, and let's have 10 there. Okay, so let's quickly remove this. What we're going to do is input I is equal to I. We are going to need a different memory space, otherwise we are going to end up writing to the same memory space. So over here it should be casted back into an int data type. Let's call it val, so it's easier. Int args, and instead of this, what it should be doing is printf value of val. Alright, so let's remove this. No need. I'm not going to go through that again. Wait. So now this one is basically what we have in this single threaded code. The only difference is that this one is multi-threaded. Okay, so we create an array to store the value of I. Otherwise you should try this one out. Actually, instead of creating an I, create a variable called I0. Okay, and then store I there, and then pass I0's value here. You guys will get a different output, so just try it out. It's very that happens because all the threads are writing to the same memory space. So not all the threads, it's this for loop right in the same memory space. Okay, so Let's compile this. Multi.c hyphen o dot out. V is a small issue. Oh, it's S. Oh, it should be D. Okay, let's compile again. We are good to go. And let's check the time this one takes. So let's check that. So the single threaded one took like 38 seconds. 38.152 if I'm not mistaken. So let's check how much this one takes. So there you go. It finished in 4 seconds. 4.342. So this one is like 9 times faster compared to the single threaded program. But as you can see, there's a small issue that even though like we call this thread one after the other, so what happens is that I gets the value of 0, then call the print function, and then it passes 0 through this value. Okay, so the 0 is the first value that's passed into this print function that gets executed in different thread, and then we create another thread, and in that thread we pass 1 and it gets executed, and so on. But over here 3 is the first value that's printed, 3, 5, 1, 9, and 0 is over here actually. Okay, that's happened because these threads don't get executed sequentially. So like there isn't an order, so that's one downside if you look at it in a way. So we call this asynchronous programming. So things don't happen one after the other. So the function that got passed, 3 got executed the first, 0 had to wait for a little bit even though it's the first one. Okay, that's what happened. So as you can see, it improves the performance vastly. So if I like check the time again, I don't think that's necessary, but let's just take it out again. So it's gonna take quite a long time, 30 seconds or so. So yeah, that's multi-threading. So what we are going to do is that we are going to apply this into our web server. The only difference is that we won't be using pthread join because there isn't a simple way to track the thread. So there's a concept called thread pools, and for that you're gonna need linked list and stuff, and I doubt that most of you are familiar with that at the moment. Because of that, I didn't implement a thread pool. Okay, so for that we are gonna use a different method to terminate the thread. So over in pthread join, so let's go back to the whiteboard. So in pthread join, it joins all the threads. In pthread detach, it just destroys the thread. Okay, so that's the difference. So like let's say that I called pthread detach on these instead of pthread join. So there's obviously going to be one thread that continues. So this is the original thread. It goes like this, and there's other three threads. Once they are done, they get executed from here. They get destroyed from there. So those threads no longer exist, and no need to join as well. So one downside is that they won't be joining. They won't be waiting until the thread is joined, because we aren't joining the thread. So as you can see, there's the time difference. Here's the here's the time that multi-threaded program took. Here's the time the single-threaded program took. Okay, so that's what we're going to do to our web server code. So let's go back to that. Let's go back to the original. Okay, let's go back to VS Code. Okay, so I came back to our original project. So what we are going to do is that first of all we need to import the import. It's still initializing. That's called pthread.h header file. So that's how so using that pthread you need this one for all those pthread create and those type of functions. So there are, if you take a look at the main for loop, okay, so what we can do is that, technically speaking, we should be able to do send cached file and cached response in their own threads. Okay, so what we are going to do is we're going to create a new thread, p30 thread. All right, and over here send cached file. So yeah, hopefully you guys can have an idea. I'm not gonna do it to everything, just gonna show it in one function. Okay, so all they should be executed in different threads. So what I should be doing is that, first of all, I need to create a a structure to pass these arguments, because we can only pass void pointers. So what I'm going to do is struct, let's call it con args. Then for that I have to pass, where is it? Oh, there you go. It's over there. So I'm gonna multi-thread this send response function. So it's gonna take one sock fd, and then I need this one actually. So send response, and then it's gonna take file path. I think it's in the method as the method. So where is it? Send response. Nah, I'm gonna need that. I don't remember. Send response. Oh, there's in. It should be the code. Mr. Created a. Oh, there is response over here. In code, it's called code, and then file path, message, and content type, content. Right. So over here I created a structure. Alright, and then what I'm going to do is, where's this send response? So here I'm going to pass a void pointer instead, and if I go to this send response, so the line is 253, 253. Okay, and then what I'm going to do is, the first thing I'm going to do is struct, should be struct conargs, let's call it conargs is equals to, it should be pointer, conargs, let's call it args. So VIB, then void should be args. Okay, and it should be returning a void pointer as well. I think I forgot to do that update here. Yeah, we'll do it. So it's return point down. So I casted it now. So what I'm going to do is, so the easiest thing I can do, okay, so you guys can see this, it gave me some errors. So what I'm going to do is, then I'm going to create new variables called code. It's going to be equal to code. Okay, and so I'm gonna keep doing this. So message, so message is going to be, it can be a char pointer, or you can create an array as well. I'm going to create a char pointer, it's easier. Connotes be message. I don't pass the method here, do I? I don't need that. And then paste it here. While path is path, and then it's gonna ask for socket d is equal to and then I'm gonna use the content type. Content type, there we go. And I think we got everything. Yeah, we got everything here. Okay, so the errors I'm getting, yes, we'll address this later. So then what I'm going to do is so this isn't the best code you can write, because like this is kind of a messy. Okay, but because you all won't be submitting this code, I'm not gonna like really restructure the code right now. So what I'm going to do, okay, keep the thread off here. Okay, and then what I can do is that so there's one thing that's certain, that let's create start connotes dot sockfd should be equal to sockfd. So I can make that update right now. So from here what I'm going to do is I have to connotes.sockfd, so it should be old, should be 405, and then strcpy. So that's how you copy a string. Okay, so file path should be this thing. And that's it. And paste. And let's call it a message. It's gonna be text-based HTML. So you have to keep doing this for all of these. Okay, wherever you call send file function, you have to do that. And what you should after, so over here I construct the argument, and what I call is p thread create. Then I pass the thread, and then no, what is it? No attributes, and then the function. So it's gonna be send response, and then I'm gonna pass the memory address of connection max. So that's how you can multi-thread this sending file process. Okay, so there's one thing you need to do once send response over here. So this is the send response. One thing, it should return null because it expects the value to be returned. The other thing is that once this thread is done executing, you need to destroy it. So it should be self, and that's it. So yeah, that's pretty much it. and now what I have to do is keep updating these 3 instances of is it 2 or 3? So 2 instances of this function as well. Okay, so once that's done, it will get executed in a different thread, and once it's done, with this line the thread will get destroyed. Okay, and then you should uncomment this, and there's a small thing. So over here we need to pass the value for a unique what is it, for a unique identifier. So as you can see, you might get an error if you execute this right now, because if you take a look at this here, it takes 1 2 3 4 5 it has 5 placeholders, but I'm only passing 4 values. So if you execute this right now, obviously I'm going to get an error for these two lines, but you'll get an error for this as well. So what I need to do is, so what is it, it's this one. So if you pass m time, wait a second, give me a second. All good. So yeah, so this fs stm m time, you pass this value for, so that the browser can uniquely identify this resource. So that's pretty much it. All I have to do right now is update these instances of this send response. Okay, I'm not gonna do that because it's obviously gonna take some time and obviously does nothing, because right now the concept is done. Okay, if you guys have any issues, just come and meet me tomorrow. I will try to help you guys whatever the way I can. So hopefully this clears everything out. So here we did 3 types of optimization. We multi-threaded, we cached both from the server and from the client side, and then we send instead of sending data as a whole for one file, we start sending data in cached file, in chunked files. All right, so hopefully that's it. And if you guys have any issues, so I went through this one a little bit fast. Okay, obviously some of you might have issues. So if you guys have any issues, just drop me a message or meet me tomorrow. I will see how I can help. So yeah, that's it for this one, guys. Yeah, hopefully see you guys in the DSA Kuppis. So yeah, hope you guys have a great day. Bye.